In this video, I want to finish up the introduction to object-oriented programming in C++ by adding to the rat class the ability to read and write. So I want to be able to do something like this. If I declare x to be a rat and y to be a rat, I want to be able to write the rats out directly like I can do with ints, right? So for example, if I say that I have an integer I, then in C++ I can say cout I. No problem. I can print the object directly. I want to do the same thing over here with my rats. Now earlier, in one of the earlier videos, we saw that I could use the getters to print out a rat, but that doesn't let me print out the object itself directly, right? We saw we could do something like cout if x is a rat, so I could say x dot get numerator, and it's going to get the numerator, and then I can do the rest of it, but I want to be able to print the rat directly, right? So how do we do that? So it turns out that if you look at the class definition, at the very bottom, it has functions, and it's overloaded operator left shift and operator right shift. But notice there is no definition of those functions in there, and there's a strange thing that says these are friends functions, and so on. So we want to talk about what friends are, and why, and we also want to talk why don't I define the left shift and right shift operators for input and output as directly in the class as member functions. Why can't I do that, right? Why can't the IO functions be the regular member functions? So that's actually quite interesting, and it touches on things that we've seen earlier. If you recall, if I wanted to do something like this, if I would remember the plus operator, if I wanted to say 5 plus x, where x is a rat, so I couldn't use the member function plus directly, because the member function has the following syntactical requirement. The thing over here, this has to be an object of the class itself, right? So if it's a rat class, the thing on the left has to be some kind of rat. And then I would say dot, and then I would say whatever function it was with parameters that belong there, right? But in this case, I can't do that, right? Because that would mean something like this. It would mean take a 5, put a dot, and then put operator plus, and put x in here. So the operator plus with an x, that's okay, but the thing on the left has to be a rat, has to be an element of the rat class in order for the thing to work. But clearly 5 is not a rat. So we have a similar situation with the IO functions. Imagine that I have the output, right, the left shift operator, to be a member function. So I wanted to say something like this. I wanted to say cout, and what do I want to print? I want to print x where x is a rat. So if I'm overloading this with the operator left shift, that would mean that the translation of this would have to make sense. I would have to be able to say cout and put a dot, and then put operator left shift, and then put an x. But I have the same problem as I did with trying to say 5 plus x, because the cout object, it's a class object, but of a different class, right? That belongs to the OStream class, the class for writing things, and it does not belong to the rat class. And if I'm going to have a member function, I have to be able to call a member function directly on a rat object, not on an OStream object. So you see, I can't do this. I have to do what I did in order to solve the 5 plus x problem, namely, I'm going to now define a 2-parameter overload of operator left shift, just like earlier we defined a 2-parameter overload of operator plus, right, to solve a similar problem. So what that's going to look like is the following. It's going to be called operator left shift, and what's it going to take as a the parameters? What are going to be the arguments that I pass in when I say cout? I'm going to say cout, and then I'm going to say x. So the leftmost parameter is going to be an argument to take an argument that's a cout object, and then the rightmost one is going to be a rat. So how do I say that I'm going to get an OStream object? How do I say that? So I say it's an OStream, and I'm going to say it's a reference. I'm going to call it OS, right? That's going to be my first parameter, and cout's going to go in there. So clearly I have to have an OStream object because I want to print something out onto the OStream. Cout is an example. It's an OStream object. Why do I want to pass it as a reference? Well, because I want to be able to change it, right? Whatever I'm printing out, when I want to print out X to the Cout object, I'm going to change the internals of the Cout object. Cout is a very complicated thing internally, but basically the way we get things to write is we write things into the Cout. It has internal buffers, which are very large arrays and so on. So that's why I have to make it a reference, because I want to change the OStream object. I'm just calling it OS. I could call it Mickey Mouse, like anything, but this lets me know that it's an OStream object. What's the second going to be? What is this parameter going to be? So that is clearly going to be a rat. So it's going to be a rat. So right here that it's a rat object. I'm going to call it, I don't know, maybe R for the right-hand side. Now, should it be a reference? Well, rats are pretty small objects, so it doesn't make a difference if I pass it in as a reference or by value. But as we saw the last time, I might want to say that it's a const, so that whoever is going to implement this thing is not going to change it. So it could be a const rat reference, let's say R. That's sort of fairly typical, right? So what's going to happen is when I call this, when I say cout R, the cout is going to be transferred into the OS parameter, and the X is going to be in R, right, as a reference. But it wouldn't have to do that as a reference. Now, what's going to be the return type? We're going to see in a little bit. So what do I want to do? What do I want to accomplish when I say cout left shift R X? What do I want to do? So basically, let's say R has a numerator and denominator. Let's say X is 2/3, right? So what I'd like to do is maybe print to the screen 2 and then a slash and then a 3. So if I were to say cout, if I were to say this over here, right, cout X, I want it to print a 2 followed by a 3. So that means I have to print this 2 is going to be the numerator of my X object. My X object is going to go in here to R, and the 3 is going to be the denominator. So I could do something like this. I can say to the OS object, right? I write it in terms of the parameter, not in terms of cout directly. I want you to put R dot numerator, and then I want you to print, let's say, a slash, and then I want you to print a R dot denominator, and maybe go to the next line and L, right? So that's gonna print 2/3, and then I'm gonna do the following thing. What do I want to do now? Now, printing, you would think that printing should be a void, right? It makes sense that I might want to return a void over here, but that's not what's done. We don't do that. What I'm going to do is I'm going to return OS, right? I'm going to return OS. The parameter, the OStream that I passed in this case it's cout, I'm going to return OS. We'll see in a moment why. And I'm going to return it as an OStream, which it is, right? It's an OStream object, but as an OStream reference. So this is actually interesting, right? It's going to come out as an OStream reference. OS goes out like that, and that is the end of my function. So this is how you actually describe the operator left shift for the rat class. Now again, just make sure that you understand why it can't be a member function, because cout is not a member of the rat class. So I can't have I can't have cout, the wrong kind of object, as the target of calling operator left shift if that would be a member function. So I have to do the same thing I did with operator plus if I wanted to have 5 plus x, and overload this to be a 2-parameter function. That's fine. That is very, very good. Now at this point, what you should have been asking is we have the numerator and denominator, those are private. So how in the world can operator left shift, which is not a member function, how can it do this, right? How can it do that? How can it say r.n, r.d? Because the numerator and denominator of rats are defined in the class to be private. So that's where the idea of a friend comes in, right? A friend function, F-R-I-E-N-D, right? I think that's how you spell friend. A friend is a friend function is a function that is not a member function, but it has access to the internals of the class object as if it were a member function. So for example, if you have a neighbor and your neighbor is a friend, or if you have a friend who's not a neighbor, you have a friend, and you're going away, and you want to make sure that your neighbor feeds your cat, or your friend feeds your cat, because you don't want to come back in 2 weeks and find, a dead cat, or you want to make sure that your friend waters the plants. So, and you trust your friend, so you give your friend the key to your house. So your friend can actually do anything in your house that you can do because you gave him the key, right? You trust your friend. So that's the same thing with friend functions. Friend function, we essentially open up the class to them, and we give them access to the internals of the class as if they were member functions, right? That's what's called a friend, and now that's why I can do things like this. I can say r.n and r.d. Now I could have gotten away without this, right? I could have said r.get numerator, r.get denominator. So in this case, I'm really not saving that much, but when I have more complicated classes, it's much nicer to be able to write, to have access. And sometimes you absolutely need access to the internals, because you can have things that are private that can only be called, you have private functions, which we didn't discuss, that can only be called by class members themselves, and friends could do it as well, right? So there are cases that's absolutely necessary. So that's what friends are. So that's why we declared these two functions to be friend functions, right? Because we needed them to get access, or we wanted them to have access to the internals of the class. So we answered two questions. Why aren't they defined within the class? Because they can't be, right? They can't be because they have the wrong struct, they have the wrong object on the left-hand side of the operation. And why they had to be friends? Because if they weren't friends, they wouldn't have access to the internals of the class. Finally, we have to address the question of what is this return type? I mean, why am I returning anything at all? Because you would say, well, printing just prints, right? So why do I have to return something, and why specifically do I return, in this case, cout? So the answer is that, notice, can I do the following thing? Let's say I say cout, and then I say, let's say x, right? Forget these classes right now, just in general. Let's say I is an integer, and then I want to print out, say, a string that says hi, and then I want to print out some, let's say, float, let's say z, and so on, right? And I can do something like this. So the question is, how does that work exactly? I'm printing out an integer, printing out a string, I'm printing out a float. How come? How many arguments does this left shift actually take? And the answer is left shift, as you see over here, only takes 2 arguments. It takes a stream. Here's the stream, right? And it takes the object that I want to print on the stream. If that's the case, and that's true, if the case is that the left shift operator only takes 2, then how in the world can I do something like this? Because I'm passing in what? I'm passing in an I, and then I'm passing in a hi, and then I'm passing in a z. How does that work? So the answer is, it has to do with something called chaining. Chaining means that I can chain together a whole bunch of these operators, right? So in other words, what really happens over here is that first I'm doing this one, right? I'm doing a cout left shift I. Then after I do that, I'm going to apply whatever comes back from here. I'm going to do something like this. So in order for this to make sense, right? In order for me to be able to then say left shift again, I have to be able to put hi into something. So that's why when I say cout left shift I, what it's going to return is cout. So then when I say hi, when I say left shift hi, the hi is going to go into cout. And so it's going to put that in the buffer too. And then I'm going to then do the next one. I'm going to put z into the cout that comes out over here. So I'm chaining these brackets, these left shifts. Right? Every time I use a left shift, the left shift only lets me have on the left-hand side some kind of output stream, and on the right-hand side some kind of whatever the object is, right? But then it's going to give me back the output stream so I can chain and do the next one or the next one. Consequently, if I want my operator left shift to work in the same way, so when I say, let's assume again that x is a rat, So I want to print out the following. I want to be able to do, and I want to be able to integrate my left shift operator and my rats into the system. So I want to be able to say, look, let me print a rat. So I'm going to say cout, the rat x, and then let me print the integer I, and then let me print the word hi, and so on and so forth. So what's going to happen here is I'm going to put x into the cout object, as you see that we did over here. But then it's going to return after it finishes printing out. When I say put x into the cout object, it means this part over here. Put the numerator and the denominator in here, and we're changing the internals of the cout object, and eventually it's going to get printed. Right? It decides its own good time when to print, or we can do it ourselves somehow, but that's not important right now. But what I want to return after I do that, after I essentially accomplish the printing, is I want to return OS. What is OS? The value of the what's in OS at this point. Well, we put cout into OS, so this is going to return cout. And then after return cout, I'm going to put the integer I in here. And that's going to return cout, because that is the way they wrote it. And then I'm going to put the hi in there, because it's chaining, right? So I want to do the same thing that C++ does with its built-in types, and I therefore make my cout my operator left shift able to do chaining. Now, just as an aside, how is it that I can say cout an integer I? How is it? Because the designers of the compiler, they did exactly what we did over here. They wrote an operator left shift that looks like this. Their operator left shift has the same structure as ours, pretty much. It's a little bit more complicated internally, but it's also called operator left shift. It also takes an OStream reference, call it OS, and it takes an integer I, or some kind of integer, whatever the integer is. And so therefore, when I say, and it has a body that does whatever it needs to do, and so therefore, when we say something like, I want to cout an integer, say integer I, so into the OStream parameter goes the cout, and into whatever this is called, let's say it's called J, into the integer parameter J goes I, and it does pretty much the same thing. So every built-in type, the integers, the floats, the chars, the bools, everything, if you go to look in the library, the IOStream library, which is do input and output, there is an overloaded operator left shift that does that. It's pretty cool. It's a very nice way to do things. What about the ability to read, right? I want to be able to do the following. I have a rat, and I want to say, take my rat and print my rat. So this is sort of a mirror image of what we did before. We define an operator right shift. And what are we going to pass in? Well, if you look at this, obviously, for the same reasons as we saw before, I cannot make this a member function, right? Because then I would have, on the left-hand side, if I were to say, I would have on the left-hand side, I would have a cin, right? Cin, and then it would say dot operator, the same exact idea, operator input, right shift, and then it would have a rat. But this doesn't work, because we saw that if operator rat is a member function of the rat class, it can only be called with objects of the rat class on the left-hand side. Cin, just like cout, is an object of a different class. It's of the iStream class. The other one was the OStream class. This is an iStream object, so I can't do this. So we have to do the same trick as we just did. We have to define a two-parameter function that takes an iStream as its first parameter and a rat as its second parameter. So what this says, just make it a little bit clearer, this says, I have an iStream, I call it, let's say, IS, for no apparent reason. I could also call it Mickey Mouse, right? iStream IS, and rat R. So when I say cin R, so the cin is going to go into iStream, and the x is going to go into R. And then what I do is, when I'm going to say cin R, cin to x, so from the input, say in this case it's going to be the keyboard, so it's going to read the first number it reads, it's going to put into r dot numerator. The next number it reads, it's going to put into r dot denominator. And what is it going to do? It's going to return the same I stream that I put in, right? In other words, if I call this thing on cin, it's gonna put it in there. Why is that? So it's going to return cin as a reference for the same reason as before, because I want to be able to say the following thing. I want to say, I want you to do cin to my rat, and then to my integer I, and then to my boolean b, and so on and so forth. So I need to do some chaining here. The same idea. Okay, so that's how input-output works. It's obviously a little bit more complicated when we get to more complicated things, but at this point, that's what's going on. Finally, I just want to address the following issue. We've been writing things sort of unself-consciously. We've been writing things like x is equal to, y plus z, where y is a rat and x is a rat, and we define the plus, and we want the answer to go into x, but we never bother defining the assignment operator, right? We did plus, we did times, all that stuff, but no, why not assignment? And the answer is that assignment is given to you for free by the C++ compiler. So if you think about this, in this case, it does the right thing, right? Because what is x plus y going to look like? So x is a rat and y is a rat. So x plus y is going to be a rat. Let's say it has 5/3. Now, y plus z, it's going to be a rat. Let's say it gives you 5/3. And what does x look like? So x is also a rat. So the assignment, the built-in assignment, is simply going to take the 5 and put it over here, and take the 3 and put it over here. So it's going to do the right thing, right? So you get that for free. In fact, there's a bunch of things that you get for free. In fact, there are 6 things you get for free. But we're going to just look at the first 4. We get, this is the assignment operator. You get that for free. You can define your own if you want. You can overload the assignment operator, but you don't need to do it for this class. You also get a default constructor. So if you don't define any constructors at all, it will give you a default constructor. It'll make one for you. It's going to synthesize one. Now, how does it know what to do? Well, we'll look at it in a second. But you get one of those. But you only get it if you did not define any other constructors. If you defined any constructors, then you're not going to get a default constructor. If you write any constructors, you don't get the default constructor. If you want one, you have to write it by yourself, right? We'll see that in a second. And then you also get a copy constructor and a destructor. We haven't spoken about destructors. We haven't spoken about copy constructors. A copy constructor is a constructor that's used when you pass parameters by value, right? Those are the copy constructors. The default constructor we saw. A destructor is a function that could be called when your object goes out of scope. But again, we didn't need it over here. You're only going to need it if you're going to get resources that you have to return. So, for example, if in your object you needed a pointer to something from the heap, and you call new, and when your object goes out of scope, you want to make sure that the memory that you got from the heap gets returned. You will write a special function called a destructor, and it will automatically return the memory to the heap. Okay, but I just want to address this thing over here, and that question is, why did I need an assignment? And the reason I didn't need assignment is because I get it for free. Okay, there are other things that you get from C++ 11 on. You get move operations, but that is not for now.